Thank you so much, Hemant, and a very good morning to everyone. And thanks to this global warming and erratic weather, my Wi-Fi is slightly not working properly, and my laptop. And very warm welcome to everyone. And today we have, I really welcome Architect Sankalp from CEPT in this webinar. The webinar is on rethinking bamboo through design. And we have been doing this webinar with Council of Architecture, for the last 6 months. This is 7th webinar in the series. And we do alternately on architecture, design, and civil engineering. And so this is the third one on architecture of rethinking bamboo through design. And we have understood that bamboo it has been around for a very long time, but we have not been able to really integrate it back after it was really labeled as a poor man's timber by the people who colonized our country. We could not to bring it back. We again need to reintroduce it in a better way in our culture. And that's why this whole series of webinars that we are doing through the working committee of Bamboo Society of India is on reintroducing bamboo in the culture of the people. Because if once you've introduced in the culture, people will take it off, like bamboo will really get again this due, which has been, long awaited. And also in this era of global warming, we all know about the various properties of bamboo. We have been talking about it, and I think Sankalp also will be talking, so I will not dwell on that much. And so these are the architecture, and architects really set up the stage for all the life processes to happen on this earth. And I think if we are able to sensitize people, architects, designers, and civil engineering fraternities, along with the people who are part of the building industry, not that the webinar is only for them, it's generally for the common people to understand and reconnect to them as to how through architecture we can actually reintroduce bamboo in our culture, which has been a part of parcel of our culture for very, very long. And definitely it's a material it's worth exploring for the future. And I mean, that's established fact that we all know. Only how to do it is what through design processes, and that's where Sankalp today is getting in. So with this, I hand it back to Hemant to introduce our speaker for the day. Thank you, Hemant. Over to you.
Yeah, thank you, Neelam ma'am. Okay, so Sankalp is going to talk about building on with bamboo. So Sankalp is a practicing architect, urban designer, and an academician. He has been teaching at Faculty of Architecture, CEPT University, Ahmedabad, India, since 2008. He currently holds the position of Program Chair for Masters in Architecture Tectonics at CEPT. He is also a co-founder of Thumbs Impressions, a collaborative practice involved in the design and detailing with concern for the environment and the labor of making. He sees his work as continuity of flowing ideas between academics and practice. He is interested in exploring the engagement of the body to the structural forces as a tool to experience architecture. His teaching pedagogy involves actively engaging students with modeling techniques and detailing to derive form. His current areas of research include the development of details for an emerging aesthetics of coming together of industrial and natural materials like bamboo in the wake of the environmental crisis. He has worked on reputed bamboo-based projects across India. He has also conducted several national level workshops on construction and has widely lectured on bamboo as a construction material. He's a lifetime member of Bamboo Society of India. So we welcome Sankalpa to present his presentation in front of us and enlighten us with his knowledge. Thank you. Over to you, Sankalpa.
Yeah, thanks, Hema. Thanks, Neelam ma'am, and thanks, Bamboo Society of India, for giving me the opportunity to be able to touch upon some of the issues that have been concerning today's work on sort of questions of design, especially with that. Now, I'm in a slightly different frame of mind today. The weather in Ahmedabad is good; it's not that hot. And so I thought that maybe let me bring about some of the thoughts which has been going on in my mind related to built environment in general, environment at large, and then how does the question of bamboo comes in here. So we don't have to repeat this, that our building industry is one of the most polluting industry globally. Um, we are also aware about severe climate change, somewhere excessive rain, somewhere almost like a drought conditions. So these are the new type of situations that have emerged, and we are addressing it not only locally but also globally. Now, India is not sort of separate from it. Not only that, today we are interconnected environmentally, but we are also interconnected through information. Now, given the challenge that we have for next 50, 100 years at least, we are the generation of people who will have to shoulder some of the responsibility of providing solutions to the question of climate change. Whether we like it or not like it, if you look at today, every product is trying to sell themselves as being sustainable. Now, you may sort of think about that these products are being sold because there is a market to the sustainability, and you get a brownie points when you use the word sustainability. But at the same time, if you look at from their point of view, what they're trying to do, let's say, for example, an air conditioner company is trying to make it more efficient than the amount of energy that they are consuming it, and therefore they're trying to claim that they're more sustainable. Okay, so the question of environment is not separate from the question of climate and is not separate from the question of society. A society needs to agree on this larger changes that is happening in order to do some bit of changes which will affect the built environment. In that light, I'm just trying to argue the fact that we can no longer be in a state where either we can go to a cave age civilization, or we can go to a civilization which uses extreme energy. So the reality of this would be somewhere in between, where social, cultural, and technological change has to address the question of climate. And in that sense, architecturally, what becomes important, and socially for the people, what becomes important is that we slowly start shifting towards an aesthetics which is not purely industrial. And in that sense, because it's not purely industrial, there is a possibility which engineers, architects, and all other actors of the built environment can start working on this balance. What we can think about it, where we start in an intelligent way, replacing some of the industrial material with natural material as far as possible, and therefore the taste, the aesthetics, and all of these will start changing slowly. Now, this is not a one-way process. This will be a two-way process. And in that light, any natural material becomes important. Because why does it become important? Obviously, it becomes important because it has a large-scale environmental impact. And so whether we call it timber, where there is excessive timber available, which unfortunately is not to a large extent, materials like bamboo becomes extremely important. So within that larger sort of domain, I'm trying to position this question of bamboo, and then let me sort of start uh, um, addressing this question from the point of view of, because we have to resolve this question of the coming together of industrial and the natural material. We don't know how far it will become 100% natural, but to accept this balance, what is important to know for all of us is that with the advent of industrialization and the way the economy has grown up, we have standardized a lot of products in the market. And what does standardization do is that it creates a market chain. It creates a market chain which is efficient. It reduces cost. It is more accessible. So all of these happens when any material gets into standardization. Call it steel, call it timber. If you look at timber and if you look at the market across the world, we have developed a lot of fastener systems in timber, which you can now use it on your own. So there has been a whole market and whole R&D that has worked to make timber the way it is today. So no more we do 100% handmade stuff. What we do is a mix of little bit of hand, little bit of tools. Of course, somewhere we are also moving to a completely technological age where we are using AI and where we are using 3D routers and all of the printers and routers to sort of produce things. But in short, if I bring this argument and then connect it to bamboo, what is happening is that we are in a very beautiful time as far as bamboo is concerned, because there is some significant work that has happened in the past, not only in sort of places like Latin America, but also now currently in India as well as in the whole Asian countries. So there is a body of work that has happened, but this body of work that has happened has taken two directions. One direction in which we are using generally culms, which we call as bamboo poles, and we are building buildings out of it. And you can see right from Simone Valles to sort of in India, if you look at it, Neelam ma'am herself or Vaibhav, many other people gone back. I mean, there are a series of people who have been sort of working on sort of these materials. The other shift which has taken globally is to look at bamboo as an industrial material. So what they have done is that they generally make splits of the bamboo. We sometimes call it slats, and we sort of then use glue, and then under pressure we are creating industrial materials like ply or like lumber, etc. So that is another kind of a direction that has taken place. Now, in one direction, when we are sort of using bamboo culms, the challenges which are sort of there. Sorry, I'm not using a presentation. I do have a presentation. I'll a little bit show you, but I'm just trying to pinpoint exactly what needs to be known. So what has happened is when we are using bamboo, and you see across the world, you will find that most of the time we are struggling with the bamboo, especially from the point of view of joinery, because bamboo is not as standardized as timber. Okay, so timber comes in a rectangular section, whereas bamboo morphologically is an elongated cone. That is one. So it is not same everywhere. Neither its diameter is same everywhere. Most of the species, especially particularly in sort of India, what it means is that at every stage of detailing, we are customizing it. And in order to evade the customization, you will find that many a times we are using a lot of bamboos. Of course, that is one part of it. And second part of it, why we use a lot of bamboo is because we have low modulus of elasticity of the bamboo in spite of having high tensile strength. And in order to compensate low modulus of elasticity, what we are doing is we are using a lot of bamboo. Okay. The third thing what you'll find when we are using generally bamboo is that you'll find bamboo, most of the bamboo forms are generally either small straight forms which has got intermediate support, sometimes trusses, but generally these forms are in compression based systems. So you'll find all the forms that you see are in compression. Again, why? Because obviously it has low modulus of elasticity. Over a period of time, because of creep, you will find if you make a straight one, there is a slight deflection. So what you generally do is when you are making it most of the time, you create camber and sort of you make a form of this kind. Now, so somewhere in these are the two stories which are sort of going together. One story of industrialization is happening rapidly. China, Latin America, even in India now it is happening. Of course, we are not doing at the frontiers in the way China or some of the other parts of the world is doing, but we are sort of doing as well. Now, somewhere in between, I think, is where a lot of work is still left. It is how do you standardize fastener systems in bamboo in a way that it is accessible to urban areas, because not all the time we are getting the skills what we require in order to produce the aesthetics. So a logical balance would be um, to look at customization on one side, somewhere in between, which is in between customization, standardization on somewhere in between, and the third is completely industrial products of bamboo like lumber, plywoods, etc. So these are the three things which we sort of need to sort of look at it. Also, from the point of view of government policies, I feel that the impetus has to be there in all the three areas. Now, the second area, what I'm talking in between, is where not a lot of work has happened, not only here across the world. I know some of the patents have been done in sort of Germany and some other parts, but it has to go way ahead of what it is currently. So so what it also means from a policy point of view, that lot of R&D efforts has to be put in place there. It has to be put in place in academic institutions, in better practices, in research-based organizations, simply because one, that this is the future. Second, it has still a lot of potential to be done. So giving this as a background, I will sort of go a little bit to talk about that whenever you are looking at bamboo, it would be good to recall comparison with steel and timber and other linear materials, because then you can understand the difference very quickly. So I'll show a quick presentation. I'll try and be quick and only touch upon points which is necessary. And then if you have questions, we can go to the questions. Okay, so I have just put some of the slides for you to just think when we'll be discussing the bamboo, but I've just put it for other materials. So if you look at it, you have got left side timber and you have got steel. One is box section, another is I think it's a channel sections, and then there are some other sections. But you see how these joineries are sort of worked out, and you see the expressions that is coming there. So one of the clarity, if you look at all these images, is uniformity of the section. So it is very clear in all the three cases, the sections are uniform. Okay. The first case, of course, you can see. The second and the third case is an articulation of a similar system. Okay. It is sort of orthogonal form, but in the way it is articulated, it is slightly different. So if you look at in between one, the way it is treated is almost treated like what timber was earlier treated. Okay. And the right side is where profile sections in steels are used. So one of the better ways in which profile sections are sort of used. Okay. And I have put the left one is because you can compare it with the in between box section. So you see that there is some way that there is an intermixing of the knowledge which is continuous. So it is not that bamboo has not been used since ages. It has been used since ages. Some of the ways in which bamboo has been used, timber got into that. Then so from timber it got into steel. So I would say that it is intermixing of the things, but somewhere in the history what happened is that a lot of impetus was put into timber, because of course it is easy to work with timber as compared to bamboo. And if you have worked with bamboo, you'll realize that every joinery is new, every bamboo is new, which is different from a standardized section of bamboo or steel. Okay, so that's what a comparison what that you will have to put it in perspective. Now the right is, I think, both wrong if I'm not wrong, but what you can see is again compression based systems, bundling of bamboo. Okay, then you find this kind of a systems in which bamboo has been bundled, but it is bundled in a way that it works like a deep section. So and then when it works like a deep section, what you need to observe is that the in spite of the fact that it is simply supporting, there are other diagonal members which are working, and why they are working is because they are trying to reduce the span of the bamboo, because they are then trying to prop it and shorten the load path. And that you will find constantly, because one of the observation with bamboo has been its deflection problem over a period of time. And so these are some of the examples of it. So if you look at it on the left and then on the right, you find and then on the third, if you see is that you will find that there is a difference. So in between one is the way in which now most of the modern construction are being done, where the beams are passed over the bamboos, and then there is either intermediate cleat or some support on which the bamboo rests. On the right one is somewhere in between, where there is a fish mouth joint that you find that is being used. So if you look at here, when there is an intermediate member which is being used, one bamboo which is vertical is trying to support your beam, another bamboo that goes up is trying to support your roof. So each bamboo independently doing its job, and then you are customizing bamboo in order to support the other member onto the top. If you go to the left, what you'll find is you don't want to customize bamboo in terms of constantly making a new fish mouth joint, and therefore it is easier to do it by having a joinery on the left. Okay, and then there are some standardization attempt that has been done in the across the world. So this is Latin America, and of course because it has got a very good species which is almost straighter, it's Guadua. So you look at the saddle detail that has been worked, and you look at the washer detail that has been worked, which has been standardized. Okay, and if you have to further standardize, I'm sure if they would have not done it, they would have already thought about it. Based on different diameters, the bamboo, you can have 2 or 3 ranges of washer. Similarly, you can have 3-4 ranges of saddle. And then once you do it, it is possible to keep on standardizing, because you have to just connect your fastener and then move ahead. And this whole story of trying to constantly customize goes. Now so this is somewhere in between stage for bamboo. So you'll find some more example, again bundled but customized, as you see here on the top. So these are some of the things which has happened. This is again in India, some of the works which is happening. Some of the works which is combination of industrial steel and sort of bamboo as a material. Again, you see compression based system. You see that attempt to reduce the spanning when there is a straightness of the bamboo, and then from there supports has been taken. So what you're constantly trying to play with bamboo is it's trying to reduce the span or trying to put it in compression. Okay. Now the smarter way it is to put all the joinery together in sort of timber and in bamboo, and when you compare it, you will, and in steel, you may see the difference what it is. Okay, that's, I'll not get into it because I'll be explaining through images anyway, but this is smarter way to sort of deal with it. And if you look at, you want to compare it, then you can put that all the 3 materials are in assembly, and you can compare the sizes, you can compare structural systems, what are kind of elements that you get, what are the modes of joining, so which is important again, and then what are the components that are being used. So I'll touch upon, I have already explained to you, but quickly touch upon what is the relationship between morphology to its detailing. So you find that bamboos are different in sizes. So you got hollow and solid section, and you can also get the split sections. Okay, there are various forms of bamboo that you can remove from. You can remove bamboo. All the red marking is the way you can sort of remove bamboo and therefore create various sections of the bamboo from it. The experiments that we sort of keep on doing it in terms of trying to find out what is the possibility with sections and particularly with splits, because in India one of the possibility what we can have is, because we don't get that much uniform bamboo, we can certainly standardize the strip sections. Four challenges which you'll generally find in bamboos would be variable diameter from top to bottom, non-uniform surplus section, shrinkage, splitting, and straightness. So variable diameter from top to bottom, one of the problem is connection, but the other problem you'll always find is that level difference. Because you have to always work with line and levels, that would be where the challenge will be. So for example, if you look at, I have sketched the center line here, and if you put it, because it's an elongated cone, the upper one is the parallel one and the lower one is not the parallel one. Okay, so you will find that on the left, on the upper one, there is less gap between the bamboo, and on the right is more gap. Okay, if you alternate it, you may be able to find equal distance. So what will happen is, when you start creating a sort of a joint which is on the side, and when you start creating those sections, you will start seeing these gaps. And so those are the aesthetics that you'll have to start dealing with it when you are dealing with bamboo. So either you select the same uniform section, or you have to deal with it creatively, or accept it the way it is. Okay. And that is then going to affect the way in which you are going to connect the bamboo, if the bamboo is somewhere in between. Because you will find that because it's not a uniform section, geometrically you will not be able to see the straightness. Okay. And similarly, when there is a line and level, I have drawn this line and level parallel line, but it's not parallel in reality. So once if you start looking at plumb and all of those, you will see that there will be a level difference. So you will have to constantly figure out how to adjust those line and level differences, etc. Okay. Similarly, when you are trying to do a widening joint, because you are trying to do two things together, again, you will see that there is a difference in sort of gap between the two from top to bottom. Non-uniform surplus section, what is the challenge? You cannot have the fish mouth joint same. Okay, so if you have cut at one point, that would be again different because the point is different. So that's another challenge which when you, so there is a different geometrical conditions in which I am trying to show you that. Okay, but the fact of the matter, it will be different. So you have to figure out these are challenges, how will you deal with it? So what do people do is people sometimes overlap it rather than try to fight with it. And when you overlap, it's a better detail. Why? Because bamboo is hollow and bamboo is a linear fiber. The moment you start cutting the bamboo like this in the perpendicular direction, what will happen is that you are weakening the section. You cannot treat bamboo joint in the same way in which you are treating timber joint with a lap joint, because that will weaken the section. And I'm talking from a point of view of architecture. In furniture, you can do some of these things. Okay. Now in India, generally, this grid I have drawn for hollow bamboo, which is like 7 to around 12 centimeter. You're in India, if you create post center to center, I have not right now created post center to center, but if you create, your grid would be 1.2 to 1.5 meter. The moment your grid will become 3 meter, 2.4 meter, there has to be a compensatory action in terms of depth, etc., or in terms of change in the spanning form. Because if you will not do, what will happen is that over a period of time, it will start sagging. Okay, so there will be a deflection that you will observe in the beam. So that's what becomes important for you. The other thing is, of course, you will have to look at the corner conditions, and sometimes you have to also look at conditions in which it is sometimes difficult to have a square plan, because with these kind of roof, because the junctions becomes complicated. You can creatively resolve it, but you need to know about it. Now, in short, because you cannot work with outer sort of bamboo, you have to always work with center line in sort of bamboo and maintain the center line. The other thing what you need to know is that if you will try to find a uniform section, if you try to find center of gravity in steel uniform section, in timber uniform section, in bamboo section, you will find that the maximum variation in CG will be in bamboo, where your geometrical center and the center of gravity will not match. In timber, it will be very less, which means that whenever you're trying to make a structure, you'll have to realize that the loading is not symmetrical. Okay, so therefore you will have to select bamboo with similar CG, if you are very sensitive with the way the structural forces will work, or you have to over design. To give you an example here, if you look at it, ideally what should have happened, all the posts which you are seeing it, if its center is where the CG would lie in any, if you are using timber generally, that is what will happen. But in bamboo, that is not going to happen. If that will not happen, over a period of time, these members, if you have not over designed, will experience eccentricity, and therefore there will be a torsion in the plane. Okay, because its CG does not follow the line as the geometrical line as what you can see here. So these are the structural challenges you will face it. Of course, if you over design it, it will work, but at least you need to know some of these things. The other very important part of it is sorting the bamboo and sorting also from a CG point of view. So when you are sorting a bamboo, as far as possible, sort it in a way that you know that you have got 30 bamboo of 12 diameter, and variation diameter when you move to 8 feet is only 1 centimeter. Okay, so you have to know all of these, because you have, when you start selecting the elements, you will have to figure out how will you put these elements. Okay, because elements, so let's say if you are using beams, then you will sort out those section sizes of the bamboo and put it together so that you can use in sort of beams and not in, let's say, posts. Okay, so all bamboos are different, so you'll have to sort out element wise and then put it there. And whenever you're trying to add and lengthen it, again you will have to work out in a way that there is some degree of uniformity. So those are the site level challenges that you'll have to deal with in bamboo. Okay, some of the images. The other problem, of course, are the splits in bamboo. As far as I know, Neelam ma'am can correct me. Still, I think a lot of work needs to be done to find out why splitting happens in bamboo. Of course, some of the conditions are related to environment, but so far, scientifically, we have not been able to grapple fully with this question of splitting. The straightness of the bamboo, if you have to see it, you have to understand that, let's say if you have to select 8 feet bamboo, you will get bamboo which are not straight. So you'll have to use thread and sort it out. When you sort it out, bamboo, and cut 8 feet of that straight bamboo, you have to also understand that the culm thickness of the bamboo has to be same. It's not only the external diameter which is important. Shrinkage and splitting, I've already told you. Now, this I wanted to mention the left, I think it's Simon Welles. But if you look at this washer, now what is going to happen is bamboo is a linear fiber. If you apply more torque in order to tighten the nut, after some time there will be a crack that you will find in there because you have over applied the torque. Now, when you are using this kind of a washer, what it does, it on the counter side, when you apply the torque, it tries and holds the fibers together, and that is why in traditional uh, sort of construction, you'll find people tie it because you have to sort of hold the bamboo from splitting. Straightness, I've already talked to you, but if you want to straighten it, you can sort of use some of heat-based treatment to straighten it. Now, as bamboo is sort of elongated cone, whenever you cut a split, that also will not be a sort of a uniform section. It will come with the diameter, or let's say the section here will be more below and the section there will be, so it will be tapered. Okay, so then later on you can grind and make it, but you have to also know some of these things, and it will have the same problem of leveling and everything what the full bamboo will have, but it is easier to standardize it. To give you a logic, in the basketry, what happens is that when you are trying to weave it, basically you're trying to weave the slats. And what is slats? Basically, slats is a standardization of bamboo, of split bamboo. Okay, because what you have done is you have sort of split it and you have reduced the section in a way that the tolerance is enough, or let's say you can play with the tolerance, which is sort of which is enough for you to get a nice basketry where you will not be able to see the uniform section deviation. But in case of, let's say you're making structure, you will be able to see it, so you'll have to figure out how to deal with it. So these are some of the sections that you can see out of split. So you will have to get these split sections. some of the examples of domes, etc., that you can make out of split sections. You can so there are some of the examples of standardization of split sections which we can easily get into it. This is some of the works that that was done by us and including our students at CEPT. This is the workshop which we did where we have used split bamboo. I think I have only one images, maybe later on I can have it. But if you look at it, the end condition when it has to be connected to it, there is the split bamboos are connected by overlapping it, and then it ends up into a full bamboo. Because if you connect it through split bamboo, then you have to either you have to bundle it too much, because it's very difficult to have those end connections. So the way we have resolved is to distribute the stress over a large area first, and then convert it into a full bamboo and then connect it. Okay. So generally you'll find in bamboo systems under pure compression, systems under tension. So the system which I showed you was system under tension and system under bending, okay, which is your frames structure. I've already talked about it. It's difficult to resolve a sort of a square plan. You can creatively resolve it, but this is like too much of a member which is coming here. And bamboo is not like timber that you can treat it like timber. It is hollow member. So you cannot have the same joinery which you are having in timber. Okay. The other thing which you have to understand is the corner condition in these kind of structure. Now you cannot make a split, you cannot make a lap joint at the corner. So you have to always create a joint which is one up and one beam up and one beam below. When this happens in case of these kind of a roofing, you will find that there will be a problem at the corner, because you will have a level difference of one kind of a slope here, another kind of a slope. So there will be a slope difference between the two sides. So in order to compensate it, I'm giving you solutions. What you need to do is either you need to have a spacer here, or you need to have an extra bamboo here in order to have level same in both the directions. Okay, then there are corner conditions which you can see it and you can creatively play around with it. I've shown you some of the corner condition, and it depends on the kind of spanning that you are sort of working with. So some of the examples of that. Now, what you need to know is, if you look at here, if you see here, the graph is on density and Young modulus. So you look at the density of steel is more than that of bamboo. Bamboo is here and SS is here. But if you look at its Young modulus, it is comparable. It is comparable. But the problem is that because the bamboo is very weak in shear, its fiber is very weak in sort of the perpendicular direction, the joineries are not able to take the full potential of its tensile strength, because it fails before that. So our job has to be to make a joinery in a way so that shear failure is avoided, so that we can maximize the potential use of its tensile strength. Okay. What are the ways in joinery and junctions gets resolved? I mean, in India, generally we use Lalpua, Stockside, Nutan, Strictest, Tulda, and other species. Hamilton, not Hamilton, I don't think Hamilton is there. Some of the species are there, and Neelaman can, maybe she can talk more on that. But I'll not get into again how to do detailing, because I have covered it at the back. I will sort of show you some of the other examples. So this is tensile one I was trying to show you. I've already talked about what is the struggle with detailing is variable diameters, splitting, and if you have to adapt to diameter, then you'll have to think about adaptable fasteners. Okay, so some examples are of this kind, where you see two kinds of system. One is lashing, another is pin, which is traditional in order to make joints and junctions. Some of the houses of that. If you have to create a landing joint, a better way is to have an extra bamboo and do it, rather than get into the way timber is done. Okay. Washer I have already explained to you before. Bundling, I have said, why do people use bundling? This is patent. Again, this is one of the example of standardization. This is another example of standardization. Okay. This I'm sure it should have been patented by now. Again, trying to not fight with the bamboo, but trying to touch with one line and then get and trying to connect with other bamboo. Now you can agree, disagree is a different matter. If you look at the bottom, these are the way in which we create uniform spacing. These are some of the way in which people have worked across the world. This is the work which we just did, where we have tried to standardize the fasteners in bamboo. This is a bus stop which we did for a triple ID workshop. And this is soon to be put in Hyderabad Ring Road, I think, as one of the demonstration of use of bamboo or green bus stop, you may call it. So this has been already accepted or sort of confirmed. Even the place has been confirmed by the government. This is the work which we did to help Bijoy Jain to make Melbourne Pavilion. So you can see Overhook was the engineer. This follows a traditional method of connections. Some more examples which you can see. This we did for and Black Studio, where we detailed out. But if you look at the corner condition, we have used timber. So we have been trying to mix steel and timber or sort of bamboo in a way that each of them is able to address their strength and sort of weakness. Another articulation of bamboo. Recently, we have also got into articulations of these kind. This is in Bihar, in the eastern part of Bihar, where we are doing the NGO campus. Again, we are looking at an expressive dimension of what when hollow and solid bamboo come together, what is the kind of spanning system that we can get. Okay, this is a large span structure, I think currently one of the largest in India, I think. Where if you look at, this is a Yogshala pavilion, which we designed and executed, which uses a mix of compression and bending based system. So this is the structure. So this one is in bending and this one is in compression. So the bending one, the truss, the top cord is connected to the compression member. Okay, and that is there to avoid the creep. So this work together as a system, and it's around 78 feet span, which would be around 24 meters. Okay, and again attempt to standardize the joineries, which you can sort of see some of the expressive dimensions of it. Okay, the standardization of joineries you can see here in images. Some of the other work that we did, this is temporary pavilion, which we did with workshopping for Raw Collaborative. Thank you. If you have any questions, please feel free.
Yeah, thanks, Sankalp. That was a really nice presentation. And I think that's one area that you have touched. I think I'm really happy that somebody is working on it, and is the joints, in a very scientific manner. And I think it's really encouraging. And I think you're working with Manu Narendran, I suppose, what I think you had told me, the structural engineer, which many architects don't have that, kind of, in fact, I do not have a very good structural engineer with me to work even now. We would want to really work together. And I think that is one area which you have touched and you're working. I think it really needs a lot of work. In fact, standardization of joints and also testing of joints. There's remained a very gray area, and that has actually limited the creativity of architects and people, because they do something and they are not aware whether it's going to work, it's not going to work. And I'm very sure at CEPT campus, I think there with all the prestigious in the institution that is, and the facilities that you have and the people around, we will have a lot of work from there with you at the hem of affairs in work in bamboo. I'm really happy that there is one question you had told about the splitting. Are you talking about splitting after the round bamboo is put in the building, or you're talking about?
Yeah.
Oh, okay. So the splitting actually happens because of the contraction, because bamboo is a hygroscopic material. And even when we, at the end of working, and we know that is around 20% of moisture is there in bamboo, but the kind of finishes we do, still it goes away because of though we sandpaper the slippery surface little bit, and we do the PU coat and other coats like that. So after the coats weather, it start taking that water. It's hygroscopic, and then when the temperature changes, it's like any other material, it splits. In fact, if you are aware, even the best seasoned wood, if it is exposed to the elements, it splits within no time. And especially in bamboo, the fibers, since they are longitudinal fibers, and we don't have, as in the matrix itself keeps on expanding and contracting because of this hygroscopic nature. And that's because of which the bamboo actually splits. And most of the splits are not dangerous till it really crosses the nodes, and that's when we have to really take care of that. So for that, and because of that, the other kind of design considerations, because of the very nature of bamboo, is like you give a long eaves, and you see that it doesn't take moisture from the ground. I mean, these are the other factors which are as important as the what other design parameters that would be. So, and I think that's true with any material that we are working with. Like if you have to work with steel, you have to understand what are its capacities and then work with it. And similarly, these design parameters come as a precursor to the design exercise that we have when we are working with bamboo. So we generally try to see that it's all like, and I'm very sure you already know about all this. It's off the ground and it has got proper eaves, and it's not. And one more thing which I do to avoid cracking is add some kind of a water body or water element around, however small it can be, maintaining the humidity in the building at a kind of a normal condition definitely reduces cracking to a lot of extent. And this because in my house and office, I both the places I house, it's very small and the roof area is quite big, still it helps. And the office, of course, it has we have a lotus pool in the center, and the bamboo is around, and it is quite exposed. I mean, it's open. I don't have a door in between, but still we don't have so much of cracking because of we try to keep that humidity. Not that we are keeping a humidity meter or something like that, but yes, I had in the beginning, and after that, we know that it's working. So it's very rare now for me to hear the cracking sound. So there is one the water body aspect that I have discovered, and to a way to maintain the humidity, and that helps. That has been helping. So yeah.
I'll just respond to that split joinery, Kritika. Just give me half a second. I'll show you the joinery.
Yeah. In the meanwhile, if anyone has any question, I think this is a very important area in which Architect Sankalpa is working. Hemant, do we have any questions from the audience?
Neelam?
Yes, sir.
I just want to know that what are the efforts being made to standardize the joinery part, because in a bamboo structure, that is the most difficult and most crucial aspect.
Yes,
so
sir.
Are they getting standardized, or every architect is discovering of his own or her own, or as per the requirement of a particular structure?
Actually, that's what it is being done so far. But I think as Sankalpa has been talking,
you may avoid this metal,
okay.
But what you need, you may avoid this metal. You can see that But what you need to do is you need to layer the split, and then you need to extend it, because what will happen is you will pin it and tie it. Okay. Now you have, this is not the best one. You have to have very less diameter pin, but that what will do is then the pin will start filling. So you have to extend it over a large surface area so that you get the strength. So you pin it and you tie it and you lap it. So from one, you bundle the split. And what we have done is then you can sort of, this split can be connected to a full bamboo. I had shown you, but there are multiple other ways, like I have used metal to do it. But these are experiments we are doing it. Okay.
This is for?
This is for using split bamboo in sort of tension condition.
Yeah. Okay. Yeah. Sure.
You can do, you have to do a lot of experiments.
Yes.
You can try with single vagara. See, you have to try and see a little bit. But what is important is if you are using, if you are using single split, no, it's difficult. You have to use bundled one.
Bundled ones.
What will happen is that if that your main split gets failed, I mean that failure happens, then it will be very difficult. So these are,
we don't work with single split actually. We always have two splits which are like that, and we slightly we put them together like that, and we put bamboo pins.
Yeah. I was responding to Kritika.
Okay, sorry.
Her question was on split joinery.
Okay, Sankalp, we have Arun Bansal sir here, with whom I actually started my journey with bamboo.
Okay.
And he has a question. Sir, can you say this?
No, yeah, my concern is that in bamboo structure, the most crucial is the joinery part of it. How do you join bamboo at different places? So is the jointing system getting standardized so that everybody need not reinvent the wheel again and again, and he can directly use the standard joinery, and the joinery which is available maybe for wood, the same thing can be used, provided the standards are developed for that.
That is where the full focus is right now.
Yeah.
At least from my side, from my whole R&D, that's the whole focus, and also from our office and everywhere. We need to reach there where we have washer, we have everything. In fact, we are also doing for split bamboo. Like you have got washer, 4 number, 12 number, 14 number, वैसे bamboo में भी होगा. And we have to get into standardization. If we don't get into standardization, there is no way out. We cannot. There is no, because nobody, you can't get people who will so much customize it and use it. That's the future we have to work for. I mean, a part of jisko karna hai customize, people are free to do it, but it will not have outreach.
Yeah, it's like when Simon Velez did that join of that what we use for with the pouring the
concrete
grouting the concrete on that really revolutionized and is being used across the world by every architect and designer to do this. Similarly, we need at least about 5-6 kinds of joints which can be standardized and with a lot of data behind them, so that we can people can actually use it conveniently and tested joints with the proper results. I mean, that's where I think the whole thing will work.
I think testing and standardization will be very important, because every architect has a fear whether this will work or not, because this is a new type of material. So everybody is under that fear. That can be guaranteed strength and other things.
Everybody cannot do R&D also, sir.
Yeah.
I mean,
it's very difficult.
It's not difficult for every architect to do that, because we have been working for a lot, so we are doing it. And so all these fasteners in our project, so we are slowly evolving. So what Rajneesh was trying to ask is that the hardwares are not available right now, because we are fabricating all these hardwares for us.
Yes.
So once we get a little more confident, then I mean it's an open source, so do it.
Yeah, actually, I have been missing my sleep for months and years together after doing a building to how it's going to work. I mean, all these more than 2 decades have been, and every time I'm also like, I don't use the same kind of stuff in the next building, even the span or even this thing or the system. It's been really, it's very tough. So I'm very sure if you want other architects to join in and more people to use bamboo, I think this standardization is very, very important and crucial actually.
Sankalp, I really like the 78 feet span structure, and this is something which um, one would not really visualize in creating a straight such a large span structure. Can you bit elaborate on what was the process of your understanding on that structure?
The thing is, 78 feet span you can only do through two ways. Either you can create compression based system or you can create trusses.
Okay.
Now, from our point of view, we were thinking about yoga and thinking about how do you connect the idea of that to a structure. And so we separated the bending member from the compression member. So what you will see is that there is a bending member. So there is a beam which is in camber, and slightly below it on both the sides there is a arch. So what happens is the top chord of the beam connects a member, a strut, onto the compression member. So once the deflection starts happening, then your compression member starts working. Right now, the compression member on site is barely working. It is just there because the beams on their own are right now. So it's the relationship that we wanted to explore structurally, and didn't want to get into conventional what Bali is kind of a structure, what people do, the Votrong kind of a. We wanted to do something, so it's a spaced bamboo again. It's not a bundled bamboo. We have all the time spaced the bamboo to maximize its inertia. So those are the kind of things that we have got into right now. Yeah.
I think every country has a different criteria of looking at bamboo and different ways of looking at buildings. So I think this 78 feet span structure is, I think, there are many institutions and many buildings that has these type of spaces and where these type of structures can be explored. So once I saw this structure, when you posted one of these photographs, then really it was really. Uh, I was just visualizing there are many spaces where these type of structures can be really implemented.
Yes. Yes. Yes.
Yeah. Okay. So, more questions. Okay. So there's Kaushik Chatterjee who is asking a question. Can you please let us know about the reliable places in India for training on bamboo construction? Okay. Sankalp, your view, please.
No, I think, I know a number of people in Bamboo Society of India who does training. Neelam herself does it. There are a lot of better people in the country. At least there are 5-6 people, sensible people who does it. Maybe it is good to join one of the workshop and do a full project. Once you do the full project, then you will be able to deviate. You will be able to accept, reject. That's a smarter way to sort of do it. But I thought, which means that this lecture didn't help.
And
I
also,
think,
actually, from our side, we have now started a kind of apprenticeship on our project sites. And one was there at the DEI at Agra that we were doing one. And we have two people, architects from West Bengal, who have joined us as apprentices on that site, and like till the whole building finishes. Unfortunately, right now the building is one building we have finished, which is around 56 feet span conference hall. The second one is around 80 feet, 80 or 85, which was just about to in the construction when some problem has happened and it has been put on hold. So they had come. So similar kind of works we are doing, where now we are accepting apprentices, and so they can join. If somebody wants to learn construction, we have been doing workshops very regularly. So
right.
that can also be there, and I'm very sure.
Good.
Okay, I
Okay.
think,
So can
we'll have to close.
Yeah. Okay. So thank you, Sankalp, for an elaborative way of understanding bamboo and other materials for a comparison. Okay, so that one can really try to relate what's going in the world. And I think there are many principles you touched to give an explanation of how bamboo works really well, and also many joinery details as well.
Excuse me.
So yeah, yes.
Can I ask a question?
Yeah,
Yeah, okay.
See if Sankalp is okay with this.
Tell
You
me,
have time, Sankalp?
tell me quickly.
There's one question, huh?
Yeah. Thank you. How do we try to overcome the problem created by the very property of bamboo related to water absorption? That is the hygroscopic nature. What are the ways people have tried to overcome this problem?
Well, I think Neelam ma'am explained this. I mean, she explained actually that part herself. One is that you don't expose bamboo. That is one. And whenever it is exposed, you treat it in a way that it has a moisture of around 18 to 20%. And if you can't manage it, if there's a water body, that also helps. Okay, so these are the three ways in which it is done. So moisture retention in timber is also done like that, because you do these coatings on timber to retain 12% moisture. But what is smartness is design, that you have to ensure that through design you don't let bamboo touch the water. And that is why, if you recall, at least I have documented building more than 50 years of age, roofing building in bamboo, more than 50 years. Not the spanning building in bamboo, sorry, the bearing building in bamboo which I have recorded is all treated bamboo. I mean, mainstream treated like CCB, etc. But traditional treatment of water, etc., I have documented roofs which are more than 50 years of age. So because it was never in touch with water, it sort of survived. So those are the ways.
I have a particular problem to mention here. When we try to use bamboo as a reinforcement in concrete structures, and maybe in whole form or split form, but whenever the moisture within that concrete comes in contact with that bamboo element, will it not shrink or expand,
No,
something
so
like that?
I see the thing is, this is going on all around. People are sharing on WhatsApp, 1 or 2 buildings out of it. As far as I know, I have still yet to find a very scientific evidence of how far it works. Okay, and you have
I
proved
have
that you
I have
asking
my building, my office in which I'm sitting right now.
but
Last
that
11
will
years,
have metal
2000.
also. That will have chicken mesh little bit.
Yeah, chicken mesh is there. Yes.
Yeah, so
Chicken mesh is there.
that takes care of the
So
shrinkage.
no, it doesn't. Not in bamboo. The chicken mesh cannot take care of the moisture absorption of bamboo. What we generally do is we split the bamboo. We don't process it at all. And it was a treated bamboo. And I have used it just like that, in fact, as a matter of fact. But the other way also to use it, that you can coat it with a coal tar or something like that. And then, some kind of a thing coating. And then you sprinkle sand over it. And that actually binds the whole thing together. Another one that I have done in the concrete in my office is also use bamboo fibers, cut into, and we have mixed it into the concrete. And so these are two elements in the, and this is the main reinforcement in my office is in bamboo actually.
So she has
And
already
it is now
given
11
you the
years.
answer.
Yeah, 11 years. And we have got a good waterproofing coat that we have done on the top. And in the bottom, even if we have some kind of cracks we had in the beginning, not because of these problems, some other execution problems were there. We don't plug it with something which is expandable. And so that takes care of that. So that is something, we have done it in my office.
Okay.
Thank you.
I think
Thank you so much.
Sankalp has to leave now. And yeah, thank you, Sankalp, for the presentation.
Thank you.
And
Thank you so much.
on behalf of Bamboo Society of India.
Thank you, everyone.
So we conclude
Thank
the
you.
session from.
Thank you, ma'am.
Yeah.
Thank you, Imran.
Yeah, thank you.
Thank you, sir.
Yeah, so, yeah.
Thank you.
Thank you, Shankar. The next session will be on design. Rethinking bamboo through through design, and that will be on design means more. It's like product design and I will take care of those in the next webinar, which will be on the third Saturday of the next month, in the month of August. So I think, Hemang, you can wrap up the session. That was an announcement that I had to make.
Yeah. Thank you so much.